Welcome back to GateX AIML. Today we'll start to understand the concept of expected value of a function of two random variables. That is, we'll try to understand expectation of joint and marginal distributions, and then using this concept we'll try to understand try to find the conditional expectation. Let us start. So previously we have found out the expected value for a single variable. Now assume that there are two variables, random variables x and y. Then how will you find it? Simple. So expectation now is given by a function. Previously there was only one random variable, so used x, only one random variable. Here it's two random variables, so it is a function of two random variables. For example, they may give it as say x, y, or it can be x plus y, x square plus y square. This is the function that they are given. Now how will you find the expectation of these joint variables is equal to same thing, summation of x, summation of y. See, in the previous case, single variable, there was only one variable, just you wrote x into f of x, this one. Here there are two variables, so the function and then the joint probability function for discrete case. Similarly, for your continuous case, g of x comma y into density, the joint density function in the integration. This is how you will find the value. It is the definition is same as your joint distribution. Only thing is, so you are finding the expectation, so you have to multiply that variable. So there are two variables here, and it is given as a function. So you will multiply this your joint density function, you will get your expected value. Let us take some example. Let x and y be random variables with joint probability distribution table given. They already given the PMF table, joint PMF. Find the expected value of g of x comma y equal to xy. They are given it as g of x comma y. The function is xy. No, you have to find e of g of x comma y. This will be equal to, so summation of x, summation of y, g of comma y into f of x comma y. What is this equal to? For all x and for all y, to multiply these values. What is g of x comma y? It is saying xy. So this is nothing but x summation of y xy. That is the function they are given into your joint function. Now, so how will you find the expectation for 0, 0, 0, 0, 1, 0, 2 like that? So, if I write it in detail, it is x is 0, y is 0, that is xy into f of 0, comma 0 plus 0 into 1 plus f of 0, 1 plus 0, 2 plus f of into f of 0, 2. Now 1, 0 into f of f 1 comma 0 plus 2 1 1 into 1 f of 1 comma 1 plus then 1 comma 2 1 into 2 f of 1 comma 2 plus, so for this also f, that is 2 into 0 plus f of 2 comma 0 plus then 2 into 1 f of 2 1 plus 2 into 2 f of 2 comma 2. So f of value is already given, so substitute it and then find it. So I think we'll get it as 3 by 14. Okay, that's simple. Now similarly, for a continuous joint variables, the function density, joint density is given as this. In the intervals, this. You have to find expected value of y by x. So what they are saying, find e of, so your g of x comma y is given as what? Y divided by x. Okay. So e of y by x is equal to integration, double integration here. This is x, that is 0 to 2. This is 0 to 1. Then g of x comma y, small x comma y, into f of xy dy dx. This is equal to 0 to 1, integration of 0 to 2. G of x comma y is given as y by x, small y by small x, the value. And f of x comma y is given as x into 1 plus 3y square divided by 4 dx dy. So this x cancels. What is this? 0 to 1, 0 to 2, y plus 3y cube divided by 4, right? Dx dy. Now integrate with respect to x first. So 0 to 1. So integrate this. Everything contains y. So it is a constant. So it will be y plus 3y cube divided by 4 into x. Because integral of 1 dx is x. In the interval 0 to 2. This will be 0 to 1. So we put the value of 2. So it will be 2 into y plus 3y cube, okay, divided by 4. Or you can write it as into dy. This is equal to 0 to 1. So y plus 3y cube divided by 2 dy. To further integrate this, we get 1 by 2 into y square plus 3 into y to the power 4 divided by 4, and evaluate definite integral. 1 by 2 into 1 plus 3 by 4. This will be equal to 7 by 8. Okay. That's it. Next. So don't worry, looks very complex, all these formulas and all, so don't mug up. So I told you to understand the concept and apply it to problems. So now let us understand the marginal expectation of a marginal distribution. So how will you find? See, very simple. E of x. The marginal means what? There is only one variable. Even if they are given two variables, it's a joint distribution. But marginal means you will keep fix one value and then add over the other values. If you fix x, I will add over y. So how will you calculate this E of x? So let us not worry about this. I will show you how. The first you are given f of x comma y is equal to integration. Let us take the summation x, summation y, right, for the function. Now let them give given g of x comma y. Now previously what you found out, the expectation of g of x comma y you found out, right? How did you find it out? Summation of x, summation of y, g of x comma y into f of x comma y, right? Now you observe here. Let us put, if I put g of x comma y is equal to x, because I am trying to find the marginal distribution of x. So will not consider y. If I put this in this, what will happen? That implies summation of x, summation of y, g of xy is x, f of xy. Now, this is, let us further simplify this. Let us say summation of x x, and then we'll put summation of y, f of xy. Okay. See, what is this actually? This is nothing but your marginal g of x, right? Y is added over fixed x. You can write it as marginal distribution of x. This is nothing but summation of x into x g of x. So what they are saying. That's it. So observe here. So summation of x g of x. So that is called the expectation of the marginal distribution. Similarly, to go for your continuous variable g of x comma y is equal to integration, double integration g of x comma y into f of xy dx dy. You take like this. See, if I say g of x comma y is x, okay, this if I apply this marginal, then it becomes double integral of x into f of x comma y dx dy. Now you just rearrange the terms. If you see here, f of x comma y dy. So let me write f of x dx. Because they're independent, I can take this out now. And then f of x comma y dy. What is this? This part. This is nothing but g of x, no? So just integration of x, g of x dx. This is your marginal probability expectation. Okay. Let us solve some problems, you'll understand. Let x and y have joint PMF. Joint PMF is given like this, and E of x and E of y. So directly you can find E of x using marginal distribution. E of x is equal to summation of x, right? X into f of x comma y. Sorry, g of x, the marginal distribution. So this will not be there into x. In the both way you can solve. Let us take the marginal distribution. That is what you have derived here, right? X into g of x. With this you can solve. Or else you can take joint PMF and solve. So this will be equal to, so x values vary from 0 to 1. This is x, this is y. X values vary from 0 to 1. So add over that values. So first you have to find g of x for that. So g of x, will you find g of 0? G of 0 is summation over y f of x comma y. Okay. So g of 0 means fix as 0. This will be equal to f of 0 comma 0. Y will vary, right? F of 0 comma 1. F of 0 comma 0, f of 0 comma 1 plus y is still 3. F of 0 comma 2. Three values are there. So f of 0 0 is 0.1 plus 0.2 plus 0.1. This is 0.40. So already got this 0.40 into x value. So every time you have to multiply this x value. This is the x value. This is g of 0. Then for all x means g of 1. So This is equal to initially 0. So x is 0. 0 into 0.40 plus next there is one more x, no? So g of 1 is equal to f of 1 comma 0 plus f of 1 comma 1 plus f of 1 comma 2. So it will be 0.1 into 0.2 into plus 0.1. This is 0.40 plus what is x value here? 1. 1 into 0.40. So this will be equal to 0.0. Similarly for y. Y means what? So x will vary, y will be fixed. So you have to find h of y. Okay. So e of y, not solve this, you can try it. E of y will be given as summation of y, h of y into y. So same thing, only here we fixed x, there we fix y and add over x values. Similarly, we have continuous function. So e of x, you can find it as integration of, so x you are finding means x interval you have to consider 0 to 1 x into g of x dx. You find g of x. What is g of x? G of x is integration marginal distribution of x. G of x is, so you integrate over y. So 0 to 1 your dy. So this will be equal to 2y, the interval 1 0. This will be 2. G of x is 2. So integrate 0 to 1 2x. G of x is 2. 2x dx. This will be 2 into x square by 2. Interval 1 0. Okay. So we'll get it as 1. Similarly for y, you find for e of y. E of y will be again 0 to 1. This will be y into h of y. Okay. We'll come to the important part. The final thing is conditional expectation. So find out the conditional distribution, right? Similarly, find the expectation of the conditional distribution where will be expectation of x given y equal to y. So this is very simple. Like your previous case, it is the summation of x because you are multiplying x and then given f of x given y. Okay. Similarly for the continuous case, if I give e of y given x equal to x, then it will be f of y given x and here it will be summation of y. Now how will you find f of x given y? Already found out. F of xy divided by h of y. So h of y means marginal distribution. F of y given x is f of x comma y divided by g of x. This is, we will not mug up these things, by these things, okay? Just understand the definition. If you understand this, what is that I have to calculate? Definitely you can calculate easily. So it is nothing but x into f of x y divided by h of y. So why we need this? Conditional expectation gives the average of x for a given y. Sum of possible x values weighted by conditional probabilities. Continuous case is integration. So useful in joint distributions, regression and prediction when one variable is known. In machine learning we'll see. Let us take this example. So to find e of x given y is equal to y using y equal to 0 or 1. Okay. So I'll solve for 0. Similarly, you can apply for 1. In the exam, it will ask whether y is 0 or 1. Okay. Here the value will be given. So let us say we'll find it for e of x given y is equal to 0. Now what is this summation of x? Because finding for x into f of x given y. Now, how will you find f of x given y? You already found it, right? This is nothing but f of xy divided by what is fixed here? Y is fixed. So marginal of y, h of y. Now, what this becomes? Summation of x into f of xy comma y divided by h of y. Now we find out h of y. So they are asking y equal to 0. So h of 0 is equal to summation over x f of the values. So how will you find the marginal distribution? I will directly write here. So h of 0 means this, fix these values. So add this 2. So 0.5. So we got 0.5. 0.5. You can write it as 1 by 2. Now substitute here. Summation of x into f of x comma y divided by, so 1 by 2 is, I will write it as 2x. Okay, I will take it to the numerator. Now x is equal to what here? There are two values, 0, 1 in this. So 2 into x, this already x is fixed, x is not fixed, x comma y is fixed, 0. So go on substituting for this. 2 into, when x is 0, 0 into f of 0 comma 0 plus 2 into, when x is 1 f of 1 comma 0. So this will be 0. This is 2 into f of 1 0 is 0.3. So this will be 0.6. Similarly, if y equal to 1, you find h of 1 and then substitute it and get the answer. Okay, you try it. Next, similarly, the same table, for a previous example, you have to find e of y given x equal to x. Same thing, only thing is your summation changes. Here you have to sum y into f of y given x. So this is equal to summation of y into f of x comma y divided by marginal. What is the marginal value here? What is fixed? So I have to find g of x because y is varying. So g is fixed given g. Find g of 0. I will solve for x equal to 0. To try it for x equal to 1. G of 0 is equal to, how will you find g of 0? Fix the table, fix x is 0 and then add over y. This will be 0.3. So g of 0 is 0.3. You substitute it here. Summation of y into f of x is already fixed 0 comma y is varying divided by 0.3. So we add it over all the values of y. So y, there are two values, 0 and 1. So y is 0 into f of 0 comma y divided by 0.3 plus, and y is 1, f of, so here 0, right? Then you are adding over y, so 0 is fixed and then f of 1 divided by 0.3. f of 0 1 is what? 0.2. 0.2 by 0.3 is equal to 2 by 3. We will see an example for joint density. Okay, continuous. So to find E of x given y is equal to y using marginal distribution hy. So how will you find? This is integral of, so x is, what I have to find? X into f of x given y. So nothing but integral of x into f. X given y is written as f of xy divided by h of y because y is fixed. Now what is the interval? The interval for this entire function. So x is varying. So x is belongs to 0 to y. 0 to y. Now find h of y. H of y means the x is varying here, y is fixed. So the interval x 0 to y. X is from 0 to y. What is the function I have to evaluate here? 6x dx. Right? So this will be 0 to y, 6x square by 2 in the interval 0 to y. This will come out to be 3y square. Right? Next, you substitute here 0 to y, x into this dx, okay, x into what we got 3y square, sorry, x into what is the density function 6x divided by 3y square dx, that is 6x square divided by 3y square into dx. So it will be 2 by y square outside because it's a constant, right? Then what is the integration of x cube x square x cube by 3 in the interval y 0? So this will be 2y cube divided by 3y square, that is equal to 2y divided by 3. This is the answer. Next, similarly, the other way, if they give like find y given x equal to x, so this will be the integral of y into f of y given x divided by what is fixed here, x is fixed, so marginal of x. Now find out the marginal value of x, that will be integrated over y. So what is the y value? 0 to 1. 0 to 1. What is f of x comma y? 12xy. And then integrating over y. So this will come out to be 12x into y square, 12x into y square divided by 2, the interval 0 to 1. So we'll get it as, put those values. So 12x divided by 2, this will be equal to 6x. 6x is g of x. Now we put it here. You are integrating over y. So interval will be y 0 to 1. 0 to 1 y into f of, this is y comma x. You can write it as f of x comma or x comma y. Okay. F of x comma y is 12xy divided by g of x is 6x dy. So 6162. So it will be 2 integration of 1 y square dy will be equal to 2 into y cube by 3. We will get it as 2 by 3. Okay. So that completes your conditional expectation. From the next class, we will go for the variance and covariance. Those are also very important concepts. Please like, subscribe and share. We will continue in the next video.